One of the great questions of cosmology is just how old the universe is. In addition to knowing just how it came to be, we thought we knew how old it was, 13.8 billion years, but that's recent thinking. There was a time, not that long ago, where the steady-state hypothesis of the universe was dominant in the scientific community. Indeed, some astronomers such as Fred Hoyle never gave up on it, even as evidence for the Big Bang mounted. The steady-state universe, in short, was that of an immortal one, where the universe had simply always existed, in more or less the same situation we see now. Its age was infinite, sustained perhaps by the constant creation of new matter. This idea of an eternal universe without a point of creation is very old, but it's a strange story. Some, but not all, current and ancient religions, such as that of the Romans and many others worldwide, featured creation myths. In other words, the universe had an age even if it was unknown, for lack of evidence to date it. But there are other cases. In the 13th century, Sigurd of Brabant advanced in a thesis that the universe had no beginning, which, as you can imagine, very much annoyed the Pope. No beginning, no creation. And that's where it gets weird, because for a time, science was going in this direction, which is the opposite of today. Even Einstein initially thought that the universe might be static, but later recanted, when the notion stopped matching what was observed. Work on redshift in astronomy, led by Vesto Slipher and Edwin Hubble, led to a sort of odd state of affairs, where Father Georges Lemaitre, a Catholic priest as well as an astronomer, suggested the Big Bang theory, even though he was a bit embarrassed over it since it sort of fit his theology. Let there be light and all. So a heretic from the 13th century led to a priest's embarrassment over the confirmation that the universe had an age. Today we know that the steady-state model is not correct, and we know it on many levels. We see the evolution of stars and how they change over time. We see the expansion of the universe. We see evidence like the cosmic microwave, background radiation, and others that are hard to explain without a Big Bang. There are just too many data points that support it, and are consistent with each other, and very little else that does not. But that does not mean that there aren't issues with Big Bang cosmology, and one of them is just how old the universe actually is. Before the commencement of the mission of the James Webb Space Telescope, the consensus was 13.8 billion years, with multiple lines of evidence pointing to that age. Recent work with Webb showed that 6 very early galaxies dating from just 500 to 700 million years after the Big Bang are too large for our models. These galaxies are huge and well developed when they should have appeared far more primitive. This has been called everything from a crisis in cosmology, which it actually isn't, to the simple suspicion that galaxy formation can happen faster than we thought. Another possibility is that it's a misinterpretation of the data, and further observation might show a different picture. It's still early in the game. While these highly redshifted galaxies probably are real, and create serious questions for cosmology, they have also prompted some scientists to start asking questions about things like redshift being wrong, or that the universe may be significantly underestimated in age. One alternative estimate puts it at 26.7 billion years rather than 13.8. While not a crisis, this has proven very controversial in cosmology, and for good reason. It's not likely to be the case. So for the Big Bang model, here is what scientists assume. The first is that general relativity is correct. This is well proven in many different ways, and it is our best theory we have as far as the behavior of gravity. Time and time again, it proves to accurately predict in the normal universe. We know it's incomplete, however, because it falls apart in environments like the interior of a black hole, but otherwise it gives the right answers. Likewise, so do our models of particle physics, and how they define the other 3 forces of nature beyond gravity. There are some hints that there may be a 5th force, but if it is there, it will be in this domain because that's where the hints are. But here again, relativity breaks down at the quantum level. Another key assumption is that the universe is basically the same in any direction you look. We occupy no special position within it. You could be anywhere, and the basics will always look the same. The last one is a big assumption, however, and it's dark matter, which could be a particle of some unknown type or something else. And there are other fundamental assumptions, such as physics works the same anywhere in the universe. Because when we look at distant galaxies, they appear to be doing just that, at least for the most part. The estimate of a much greater age of the universe is based on an idea by astronomer Fritz Zwicky in the 1920s. It's known as tired light, and it actually goes against one key assumption about the nature of light. Instead of light only being affected in a few ways by space, it can also lose energy in space here, thus get tired, and stretch to longer wavelengths over distance, causing apparent high redshift, meaning that our estimates of the age of the universe are incorrect. The idea in this context is that redshift exists, but so does tired light, creating a compounded situation giving us a false interpretation of our measurements. But more is needed to come up with the 28 billion year estimate, which was calculated by astrophysicist Rajendra Gupta in a recent paper, link in the description below. Also required is the introduction of physical constraints that change over time, meaning that earlier galaxies can exist, thereby explaining the observed discrepancy by JWST. The reality, however, is the more likely explanation is that we simply don't fully understand the evolution and formation of galaxies, and it happens faster than our models are predicting, meaning the models are wrong, or at least off. This is actually well within possibility. At the same time, however, it pays to recall the pushback to the Big Bang notion within cosmology, which at the time the steady-state hypothesis was something like a consensus. It turned out to be titanically wrong, so maybe a revisit to discarded hypotheses like tired light might make sense, just so we don't miss anything. The other issue is that if it is correct, and the universe is much older than the 13.8 billion year estimate, it goes up against a lot of other observational evidence. This includes galaxy distribution, measurements of the rate of the expansion of the universe, evidence from the CMB and supernovae, and many others. That was one of the points of criticism for the new estimate, in that it only accounted for supernova data. It's very important that any new estimate of the age of the universe, or any alternative theory to consensus, take into account all observations. Only when everything is consistent does it have legs. This means that everything from subatomic to the largest structures in the universe all have to agree with each other for your theory to be any good. A way to visualize this is observing an apple without knowing what it is. You could watch an animal or a human eat an apple, and by sheer chance have a heart attack while doing that, and then you might suspect that apples are poisonous. What you wouldn't know about are things like apple pies, millions of people worldwide eating apples because they are not just good, they're healthy, and so on. If you did know that, the overwhelming dataset would make you realize that you've misinterpreted things and that you need to look elsewhere for the cause of what you thought was poisoning. But if you come at it from all angles, knowing all data and observational evidence, you realize that eating apples is actually good for heart health overall. When everything is consistent with everything else, you're probably close to the truth. The problem with the tired light concept, however, is that it should be readily evident in several ways. The first comes straight from its originator, Fritz Zwicky. He actually saw a problem with his own theory, but proposed it anyway to get the discussion going. Zwicky realized that the light would need something in the vast distances of space to interact with, causing it to get tired and lose energy. When you do that and introduce it, you get redshift, but also another effect, a significant blurring of distant galaxies. This simply is not seen in observation, only redshift is seen. But there are other issues. Cosmological time dilation should not be seen. It is. So when you look at very distant redshifted objects, time appears to move slower for them, an effect known as cosmological time dilation. This is observed. If you look at things like supernovae and distant galaxies, the more redshifted they are, the more stretched across time they appear to unfold. This also eliminates tired light because the effect would be different. These, however, are dwarfed by an even bigger, more fundamental issue. We can see the afterglow of the Big Bang still, the cosmic microwave background radiation. When we look at it, we're seeing light from just 380,000 years after the Big Bang. Needless to say, it's highly redshifted due to the expansion of the universe. But there is a known effect here. Light redshifting from the expansion of the universe retains its blackbody spectrum. If tired light were correct, the CMB wouldn't exhibit this. But it doesn't just exhibit it. It's the most perfect blackbody spectrum ever observed. added with even further contradictions visible in the quantum world, and the end result is that tired light simply doesn't account for multiple varied independent observations of effects it cannot predict or explain. Rather, it's the opposite. So the question in the title is the universe older than we thought? Probably not, though it's science and it can be wrong. It's a process of revision, but it's overwhelmingly likely from what we observe on multiple fronts that the age of the universe is indeed 13.8 billion years old. But that creates another question. Given that the universe will continue on for trillions of years, there are some very long-lived stars within it, then why is it that life, which we represent, happened so unbelievably early? If life is rare, then not only did it appear on Earth the very first moment it could, but it also did so give or take a few billion years in the universe at large, standing further against the idea that we might be alone in the universe. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently eyeing the steady state theory suspiciously. I'm actually surprised that theory once had legs, in light that it claims a permanent creation of matter from nothing, and it's done so forever without a start, and will do so forever without an end. It just seems strange and less intuitive than the Big Bang from the start, even without knowing about the expansion of the universe. Odd indeed, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.